Alright, so here I thought I'd do a couple of the problems from our calorimetry problems 1 worksheet, just so that you could see a couple more worked out. I'm going to take a look at number 13 first. Number 13 on your worksheet says if 680 calories of heat are absorbed by 10 grams of water, and if the water is initially at 18 degrees Celsius, what will the final temperature of the water be? So if we take a look at this one, we're going to be using our Q equals mc delta T because we have a change in temperature that we're given, we know the specific heat, and we're given the mass. So 680 calories was what the total energy was, and now we have 10 grams. We're going to use 1 calorie, because this is calories over here, per grams degrees Celsius as our specific heat of liquid water. And then we have final minus initial. Remember, delta T equals final minus initial. So we can break that up and we can have x, because we're looking for the final, minus our initial, which is going to be 18 degrees Celsius. Once we do that, we can do simplifying. So we have 680 equals 10 times x minus 18, and 680 equals 10x minus 180, so I just distributed that 10 over to each one. Now I'm going to add 180 to get rid of that. And let's see, we take our handy dandy calculator. We have 680 plus 180 equals 860. So we have 860 equals 10x, and our x is going to equal 86 degrees Celsius. So that is our final temperature. So if we added 680 calories to the water at that temperature, we'd raise it to 86 degrees. Now let's take a look at number 15. So 15 says how much heat is given up when 20 grams of steam at 240 degrees Celsius are condensed and cooled to 23 degrees Celsius. So first thing we need to do is actually draw our temperature diagram so that we know how many equations we need. And if I get a different color here, so we have it starting at 240 degrees Celsius and going all the way to 23. So 240 degrees is going to be somewhere up here, and 23 is going to be down here. And since this is water, this is 0 degrees Celsius, and this is 100. So we're going this section. We have to go through all 3 of these sections. So we're starting here. We're going to condense it and then go all the way through our condensing phase, and we're going to start cooling it in its liquid phase. Now that we have that drawn, we're going to look at each section. So I'm going to label the sections here. I have A, B, C. I'm actually going to start with C first because we're going this direction. So for section C, we are going to be using our Q equals mc delta T because we have a change in temperature. It's not a plateau region. Our grams are 20 grams. Our specific heat, I'm going to use 2.0 joules per grams degrees Celsius. And then we have our final, which is 100 minus our initial. Remember, it's 100 is our final because we have to do it one section at a time. So we can only do the temperature change for that section first. So if we crank all this together, we are going to get negative 5,600 joules. So there's the first part. Now let's move on to B. B is this region right here, and that's going to be condensing, so we need to use our Q and delta H. So our moles, we're going to take our 20 grams, divide by the molar mass, and then multiply it by our delta H, which our delta H in joules for condensing is negative 40.7 kilojoules per mole. And then we're going to times that by 1,000 to get it into joules. And just remember that this is negative because we're condensing. So we're going the opposite of what's listed on your reference chart, which is vaporizing. So we need to switch the sign. That's how I got the negative there. So if we take that, we get negative 45,222 joules for this section. Now for section A, we're going to have Q equals MC delta T, since we are in the liquid phase. Once again, our 20 grams, we're going to use 4.184 as our specific heat of liquid water, and our temperature change is going to be a final temperature of 23, and we started this section at 100. If we solve that, we get negative 6,437 joules. So our last step is going to be to add A, B, and C together. So we get Q total is going to equal Q of A plus Q of B plus Q of C. So if we add them all up, we're going to get negative 57,259 joules. So that is what's required, or actually that's what's released because it's negative if we condense the steam. So hopefully that helps. Now let's see. We'll do one more. Let's take a look at number 16. Number 16 says express the heat of vaporization of water in calories per gram and in joules per mole. Do the same thing for heat of melting. So I'm going to switch back to the black, and this is number 16. So for the molar heat of vaporization, we have on our chart 9.72 kilocalories per mole. We're going to convert that to calories per gram. So let's start with the calories. In 1 kilocalorie, we have 1,000 calories. And then in 1 mole, there's 18 grams of water. So now our moles cancel, our kilocalories cancel, and we're left with calories per gram. So we get 540 calories per gram. Now we do the same thing with our 40.7 kilojoules per mole. So same process, and they want you to get in joules per mole. So you just need to convert here kilojoules to joules. So once you find that conversion factor, you'll get joules per mole. I'm going to leave that one for you guys to do. Now for our molar heat of melting, for calories, if we have 1.44 kilocalories per mole, and they want us to get to calories per gram again, we're just going to do the same process. So there's 1,000 calories in 1 kilocalorie, and we can switch 1 mole to 18 grams, and that's going to give us 80 calories per gram. And then you're going to go ahead and do that with converting our kilojoules per mole to joules per mole. So you should have 4 for that one. Alright, so hopefully this helps, and let me know if you have any questions.